Our project is the concrete canoe, and this is by Cole Hicken, Cameron Edwards, Raphael Bernabé, and Samantha Nearby. The first part of our design cycle was to ask, so we had to create a canoe that floats on water, which means it has to have a lower density than water, and the canoe also needs to hold some weight before it starts to sink. We decided the most important decision was what type of aggregate to use with the cement. We initially used pumice, which is volcanic rock, and therefore it's porous.
For our first prototype, we got around 20 pounds of cement and then 4 pounds of pumice rocks. And we also created a 3D mold that would help form the canoe. We also needed to make sure that the concrete didn't stick to the mold, so we ended up using Vaseline and non-stick cooking spray and putting that on the mold. We ended up creating the canoe on April 4th, and it took around 2 days to dry. When we took it out, it was pretty smooth, and we tested it on Lake Raleigh, but it ended up sinking, unfortunately. To improve the canoe, we ended up using microglass beads with our pumice rocks for the aggregate because they're less dense. And we also used a different mold that had more thin walls and rounded edges.
A major part that would go into the functionality of our concrete canoe would be the mold that would be used to form it. So using Fusion 360, we created our mold within the constraints of the project so that we could 3D print it within a reasonable time frame, whilst not overestimating the project boundaries. So this first iteration of the canoe was 17.5 by 9 by 4. And to the left here was the base of our mold, and this would be used to hold all the concrete within the canoe and fill it out. And to the right is the shaping portion of our canoe mold, and those two prongs on each side of the shaper would go into those two holes on the left to press down on the canoe and shape it out in the middle. And here's the first video of our prototype in action. And unfortunately, it did not float. And so after that, we made a second version of our canoe mold. And while it was very similar to the first version, with the base being the exact same, we've changed the shaping portion in order to give the canoe thinner walls and fill out the rest of the canoe, as the main problem with our first model was that the edges were too thick and it was just overall too dense. And so we also changed the mechanism of it going down into the mold too, with us just pressing down like this rectangular box down on the main base of the mold instead of the two prongs in the end.
Challenges and solutions that we as a group came upon. Finding the proper mix of aggregate to concrete and water. So in our first mold, as we said, we used pumice and concrete, and we used a 1-to-1 ratio of pumice, concrete, and water. And we put this in our mold, and it worked out pretty well, except that our mold was not designed well, as it was too dense at the bottom and on the sides. So we created a new mold that would be thinner on all sides, and we created a new mix that we calculated would be less dense than our first mix, and we used microbeads, pumice, and concrete and water. And we reduced the amount of concrete we used, but this failed in our second design, as the mix used too much aggregate and not enough concrete, making it more sandy than concrete, and didn't give it enough time to cure.
So some advice we have is to make a schedule for the research, planning, and testing, and to make sure to stick to it. You'll need time to research and figure out how to make the best model, but you also need to leave enough time for testing. We would recommend leaving about a month before FEDD for testing, so if something doesn't work, you can rework the model. And these are our references.